Hi there, my name is Molly and I am a senior in the chemical engineering department here at Mizzou. And I am a member of Omega Chi Epsilon, which is the National Honor Society for Chemical Engineers.
My name is Daniel. I am a second year student here at Mizzou pursuing dual degrees in chemical engineering and mathematics, and I am a presumptive member of Omega Chi Epsilon.
My name is Jatera Lee, and I am a junior at the university, and I am a chemical engineering major. And also, I am a member of Omega Chi Epsilon.
Hi, my name is Reagan Kruger. I'm a junior studying chemical engineering at Mizzou, and I'm a member of Omega Chi Epsilon.
Hi everyone, my name's Valerie Veneer. I'm a junior here at Mizzou studying chemical engineering, and I'm also a member of Omega Chi Epsilon, which is a really great organization for chemical engineers to come together and volunteer for, participate in, and even sometimes host a variety of events at Mizzou.
Why did I choose to study chemical engineering? I chose to study chemical engineering because I've always been very interested in chemistry and I've always been really good at math, hence the second degree. And I was looking for a degree that could combine the both. As I've learned more about chemical engineering, it's not exactly a good, perfect merger, but it's still very much interesting and very applicable in a lot of different fields I find interesting.
Why did I choose to study chemical engineering? Well, in high school, I was really good at math and I loved chemistry. But when I was looking for a major, I actually was looking for a major that would challenge me and also had a lower representation of women within the field. So chemical engineering just kind of sparked my interest, and I stuck with it all these years so far.
So I chose to study chemical engineering. So I actually started off as a computer science major when I first came to Mizzou because I had taken some coding classes in high school and really enjoyed it. I ended up switching to chemical engineering after my first semester, mostly because I really enjoyed my intro chemistry classes and I wasn't feeling super thrilled about my current major as computer science. I was thinking I was looking for something a little more hands-on. I knew I wanted to stay in engineering, so I decided to switch to chemical engineering and see how I liked it. And when I took my first chemical engineering class, my first semester sophomore year, I thought it was really fun. I loved the problem solving and the involvement of chemistry.
Two of my favorite courses so far have been my MATLAB course, which was a class that taught me how to use the MATLAB program, so writing code and things like that, and my thermodynamics course, which just teaches you a lot of the fundamentals of chemical engineering, such as how different processes work, and energy balances and mass balances and things like that.
My favorite class so far has been Organic Chemistry 2 in the corresponding lab. I really enjoyed being able to understand the reason that chemical reactions occur down to the molecular level, and also learning why chemicals react with each other in such vastly different ways. The lab portion of this class was also particularly fun because we got to create and see the things that we were learning about in class. This class also really helped me make the connection between chemistry and chemical engineering, since the products we were creating on a small lab scale are very comparable to what chemical engineers get to design and produce on a much larger manufacturing scale.
My favorite chemical engineering course is my air pollution class that I currently take. So I am from the inner city. I'm from Kansas City, and I have a lot of family members with asthma, and so air pollution and air quality is kind of near and dear to my heart. So I think the class is just enjoyable, and it's something that I can relate to personally.
Hi, everybody. My name is Eric McCarthy, and I am the Vice President of the Omega Chi Epsilon organization here at the University of Missouri. And today, I'm going to be showing you how to create elephant toothpaste. Here are our key ingredients. We have yeast right over here next to warm water. We're going to mix those two together. Next, we have hydrogen peroxide. This chemical you have to be careful with. That's why I'm wearing protection on my hands and on my eyes. And dish soap. And they're all going to be mixed into this bottle. All right, I have added the hydrogen peroxide and dish soap together in this bottle, and I have mixed up the yeast catalyst with some warm water in this cup, and now all that's left is mixing together. But I'm going to do that in a nice safe area.
Have you ever wondered why hydrogen peroxide bubbles when you pour it over a cut or scrape? Hydrogen peroxide is composed of 2 atoms of hydrogen and 2 atoms of oxygen of the chemical formula H2O2. Our skin, like many other living organisms, contains the enzyme catalase. When catalase comes into contact with hydrogen peroxide, one of its oxygen atoms is quickly released, then joined with another oxygen atom to form oxygen gas, chemically known as O2. This oxygen gas then rises to the surface and bubbles out of the solution, leaving behind 2 hydrogen and 1 oxygen atoms. Can you guess what this makes? If you said water, congratulations.
In the experiment we performed earlier, we used yeast as the living organism that provides catalase. When we poured the yeast mixture into the solution of hydrogen peroxide and dish soap, the catalase from the yeast caused the hydrogen peroxide to release its oxygen atoms and form oxygen gas. Rather than the bubbles rising to the top of our solution and escaping, the dish soap entrapped the oxygen gas, resulting in thousands of tiny bubbles in a giant tube of foamy toothpaste fit for an elephant.
During my time at Mizzou, I have worked in Dr. Ulri's lab for about 3 years. It's a biomaterials lab. So I work on a tissue engineering project. So specifically, we're very interested in trying to regenerate bone, basically. So when you're trying to regenerate bone, you not only need like the actual bone cells, but you also need a blood vessel network as well as nerves in order to have like a full working bone. So my part of the project was specifically looking at the regeneration of the blood vessels. And so we were looking at using hydrogen peroxide for this. And the reason that we were looking at hydrogen peroxide, the reason why we think hydrogen peroxide works to cause blood vessel growth is basically when you have a cell, so I'll start with hydrogen peroxide is a byproduct of normal cell metabolism. So your cells are constantly as they're creating ATP and making energy so that you can do things, they're producing hydrogen peroxide as a byproduct. And so when your cells are happy and normal, they have good blood flow, and all of that hydrogen peroxide that they're making gets taken up by your blood and washed away. So, but when you have a buildup of hydrogen peroxide, basically your cells are like, uh-oh, I don't have enough blood. And so then they go through normal processes to grow more blood vessels. So basically what we're doing when we expose our cells to hydrogen peroxide is we're kind of creating like a false buildup of hydrogen peroxide and telling the cells that they don't have enough blood flow. And so then the cells go through those normal signaling processes in order to grow more blood vessels. And so that's what I've been doing while I'm in the lab.
My freshman and sophomore year, I did undergraduate research at a lab here at Mizzou, and the lab that I worked in focused on biomaterials. So one of the projects that I worked on was essentially making this gel that we put into a bone fracture. And the one specifically that I was looking at was when the bone is a non-union fracture, so the two pieces of bone, after they break, they don't touch. And so what we wanted was this gel that we would insert into the fracture, and then using that, it would try to heal the bone fracture.
The past 2 summers, I've interned at Honeywell FMNT in Kansas City, and I've done a lot of work with 3D printing with metal parts. So everywhere from even, drawing the designs on the computers to the post-processing, where you have to get the parts all cleaned up so you can actually send them out and people can use the parts that you make.
My internship experience is a process engineering position at Catalent Pharma Solutions, which is a pharmaceutical development and manufacturing company. In the process engineering position, I was exposed to a lot of heavy machinery and manufacturing equipment that's used in the production of pharmaceuticals. I learned how new equipment gets acquired by a company and also how existing equipment is maintained and operated on day-to-day production. This upcoming summer, I'm joining them again in a formulation scientist position, where I'll get to work on a smaller lab size scale and work with a team to develop a new pharmaceutical by determining the right ingredients and also the proper equipment to use in manufacturing.
What do I want to do with my chemical engineering degree after graduation? Well, I haven't ruled out grad school for either of my presumptive degrees, math or engineering, but I'd like to move back home to Houston or near the area and work in the energy sector, clean energy, renewable, batteries, even petroleum in some way or another.
What do you want to do with your chemical engineering degree after graduation? After I graduate, I really just want to go into the industry. I'm not exactly sure what I want to do specifically yet, but I know that I want to go into the industry and maybe do something with environmental.
So I do want to go into industry, but my overall goal when using my chemical engineering degree is to create my own hair care line and skincare line, so I can help other little girls that look like me, that may have super dry scalp, or maybe they have alopecia, which means they have a lot of hair, it's extreme hair loss. It's just so helping them, that so they can feel beautiful and feel comfortable. So overall, that's what I want to do with my degree.
I do know that I enjoy the pharmaceutical industry from my internship experiences, but I'm also really interested in the environmental industry, so I actually have an emphasis on my degree, so I'm chemical engineering with an emphasis in environmental. And I haven't got to learn much about the jobs for chemical engineers in the environmental world, but I do know that I'm also really interested in wastewater and drinking water treatment facilities.
After I graduate, I am planning to go to grad school. So I'm planning to go and get my PhD. I'm actually going to be switching to biomedical engineering from chemical engineering. And the reason I am hoping to do this is I want to go into a career in research. I'm very interested in doing translational research that is impactful for patients. So I'm specifically interested in some cancer biology work as well as trying to develop cancer therapeutics.